So the topic that we are going to cover today, it's absolute dependent motion analysis. To understand the dependency of one particle on another or dependency of one motion on another, let's consider this example. So absolute dependent motion of one particle on another. So for this understanding, let us consider this example or this diagram. We are having two blocks, that is block A and block B. So both are having different masses, definitely will be having different weights. So both are connected with each other with the help of rope. And let us consider that this rope is inextensible. So definitely the question arises that why we want to study the absolute dependent motion analysis, or why we are doing this type of analysis. So in many problems, the motion of one particle is usually, sometimes it depends on the corresponding motion of another particle. So if we analyze that thing, so we will be able to solve such type of cases in which the object of one body, object of one particle is dependent on some other particle. Okay, so let us consider we are having two masses, two blocks, block A and block B. So both are connected with the help of rope, and the rope is passed over a pulley. Now this pulley, this is basically inextensible, means no extension is possible, no deformation is possible in this. Let's assume this thing. Okay, now if block B moves downward, so as a result of this downward motion, the block A, it will move upward. Similarly, if block B moves upward, or if block A move downward, so this block B will move upward. So means the motion of block A is dependent on motion of block B, or we can say the motion of block B is also dependent on the motion of block A. Okay, so what we need to do basically, we need to analyze those things, and we need to set up a strategy to mathematically solve such type of problems. Okay, so what could be the steps for studying or for analyzing such type of motion, or for studying or analyzing absolute dependent motion of particles? Okay, so let's study the step one by one. So the first step that we have, what we need to do, for example, if we are having this system consisting of a rope, pulley, and the two masses are the two particles, and the motion of both these particles are dependent on each other, these two particles. So the first step that we need to do is we need to set up our coordinate system, or we need to set up the origin. And we need to, if we are having just a single motion, or the motion is passing through a single point, so in that case we can have origin, or in some cases we may need to define some datum. Okay, so in this case, let's have our datum plane over here as shown in this case, and we need to define our coordinates, means the positive distance and the negative distance. So for that purpose, let's say this S is representing the positive displacement. Okay, so the first step is set up a coordinate S along the direction of motion from a fixed point. So this fixed point, it can be origin, or it can be from a fixed datum plane. So in this case, we are having a fixed datum plane. Now the second step is represent the distances, means from this origin, from this datum plane, what we need, we basically need to represent the distance of object A and the distance of object B. Okay, so represent the position of object. So means if we specify the distance, this means the position will be specified automatically. So represent the position of object respectively. So let's say object A is having a distance of SA from this datum, or we can say SA is a position vector that basically represent the position of object A or block A. And this SB, this is basically a position vector, or this is a distance of object B from the datum plane. Now what about step 3? We need to identify constant length. If there is any constant length in this whole system, we need to identify. Okay, so if you look at the green color that we have over here, means this semicircle portion, this distance, it will remain same, it will not change, this length will remain same. If the object A moves upward or it moves downward. Now, if the object B move upward or it move downward, in both cases, whether object A is moving upward or downward or object B is moving upward or downward, this length will remain same. It will remain constant. So that's why we need to recognize those constant lengths. Okay. So in step 4, what we need to do, we need to find out some relationship between the distances, or the relationship between the motion, or relationship between the motion of objects. Okay. So step 4 is basically finding the depending relation between the positive variables. So the positive variable in this case, as we have as positive downward. Okay. So S is positive downward. We are having SA and we are having SP. Let's try to find out some relationship between SA and SP. Okay. So we know that in this case, the total length of this cord, or the total length of this rope, it is basically equal to SA plus SB and plus this constant length. So if we combine all of them, so what we will get, we will basically get the total length of this rope or this cord or this object, which is basically connecting these two masses. Okay. So SA plus L semi plus SB, that is equal to the total length of this cord. Or another word, it can be termed as the total length of this cable or rope. Now, basically, we are interested in finding the displacement, then velocity, and then acceleration. So we get this relation, which is basically showing the relationship between, we got this equation which is showing the relationship between SA and SB. So let's differentiate it with respect to time. So in step 5, what we need to do, we need to differentiate this equation with respect to time. Okay, so when you differentiate, it will be d by dt on the left side, as well as it will be d by dt on the right side. Okay, so since this one is constant, this one is also constant. So when you take this derivative inside, so derivative of constant and derivative of constant should become 0. And what we will get d as a by dt plus d as b by dt is equal to 0. D as a by dt, this means this is basically velocity of particle A, and this one is basically velocity of particle B. Okay. So when you take VB on the other side, what you will get, VA is equal to minus VB. Okay. So the negative sign here, it basically indicates that if block A moves downward, so its velocity will be positive. In that case, block B will move upward and its velocity will be negative, because positive sign is downward. So this equation basically represents this thing. Now we can also write it like VB is equal to minus VA. So what that represent? This represent that if block A moves upward, if this block A moves upward, which is in the negative direction, it will be having negative velocity. So this block B will move downward in that case. So means if block B moves downward, block A will move upward, since downward velocity is positive and upward velocity is negative. So that's why we can have this equation. Okay. So now we got the velocities. Okay, what about other step? If you want to find out the acceleration, so then we can go through step 6. So if necessary, repeat the differentiation and extract the relationship in acceleration. So again, time derivative of left side, time derivative of right side. When you do so, what you will get? You will get basically acceleration of particle A and acceleration of particle B. So these are the few steps which we need to follow throughout our course or throughout our lecture for absolute dependent motion. Okay. So now to better understand what we have studied so far, let's consider an example. Okay. So for the pulley system, as shown, the velocity of object A is known. Velocity of object A is known. It is upward. Upward, and it is how much? It is 3 meters per second. determine the velocity of object B. So means if it is moving upward, we need to find out whether this object will move upward or downward. So we can identify this thing from general observation by looking at the diagram, but we also need to find out the exact value of velocity at B. Okay, so let's apply all those steps. So the first step is basically setting some datum plane, let it be here, and then the second step will be specifying distances. Okay, let this one be positive s. Then we need to identify the distance of object A, similarly distance of object B. So let's look at it. So the first step is set up a coordinate along the direction of motion from a fixed datum line. Okay, so let this one be the datum and let this be the positive distance or the positive displacement. Okay, now represent the position of object respectively. Okay, now one thing we have to note down here, that in this case we are having two ropes. In this case we are having two rope. One rope is here and one rope is here. Okay, so this is having its own length, this second rope is having its own length. So what we can do in this case, we can define this one length as A, and the length of the different length of second rope as with substitute B. But to find out the relationship between these two, the object A and object B, what we need to have, let's have another distance, or let's have another s with subscript C. Why we are defining this SC? It is just to find out or to just maintain a relationship between SA and SB. So the equation that we will get for object A, it will be between SA and SC, and the equation that we will get for object B, it will be between SB and SC. So SC in this case, it is like acting as an intermediate relationship between these two. So I have mentioned all those things over here. Since the system has two chords with segment that change length, so it will be necessary to use a third coordinate, that is SC, in order to relate SA to SB. Okay, so let the position of object A from the origin or from the datum be SA, the position of object B from datum, let it be SB. Okay, then the position of this point till this point, let it be SC, and it is also mentioned over here the position of this point, which is basically pulley C, from here till the datum, let it also be SC. Okay, so the third step is basically to identify fixed lengths. What we need to do, we need to identify the fixed length. So this length is not changing, one in green, this is not changing, this is also not changing, this one is not changing, again this one is not changing. So what we did, we set up coordinate and then we represent the different position of objects. Okay, then in the third step we identified the constant lengths that is not changing, those lengths which are not changing in the analysis during the motion or within the given system. Okay, so in step 4, what we need to basically derive the relationship between some dependent relation in which the one motion is dependent on another. So what we can do, let's first consider one rope. It can be this one or it can be this rope. So first let's consider one of the rope from here. It can be this rope or it can be this rope. Okay, so let's first consider this one, the one shown in the blue. So if we want to find out the total length of this rope, it will be SA, then this SC, and again SC. Okay, and then we have this constant, and we also have this constant, and we have this constant. So let's combine all those constants into one and let it be C1. So what we have, SA SC, SC in C1, and this is basically the total length. This is basically the total length of rope 1. Now for B, let's have SB and then this one. So this length will be basically, if this is SB, if you subtract, if this is SB, if you subtract SC from SB, so what we will get? We will get this length. We will get this length, this one. Okay. So SB minus SC plus SB, and again the constant that we have over here. Okay. And then the constant that we have over here. Let be combined into C2. So it is equal to the total length of rope 2. Okay, so we identified this relation. Okay, now let's rearrange this equation. SA plus SC plus SC plus C1. So when we arrange it, what we will get? We will get this equation. Also arrange this one. When you arrange it, we will get this equation. Okay, so now in this case we need to remove this SC. It is having negative sign over here. So if we multiply this equation with 2 and then add with equation 1, so we can remove this term. So in order to cancel out SC, multiply equation 2 by 2 and then add equation 1 and 2. So when you do so, what we will get, these two, it will be cancelled out and we will get this equation. Okay, so this LT1, LT2, this C2, this C1, all of them are basically constant. So let combine all those on the right side and the other one on the left side. Okay, so we get basically this equation. Let all these constants be equal to a single constant C. So differentiate it with respect to time. When you do so, what you will get? You will get this equation, dSA by dt plus 4 dSB by dt. Okay, and that should be equal to 0 because derivation of constant is 0. So we get this equation. Okay, so we are given with VA and we need to find out VB. So take VB on to one side and VA on to other side, we get this equation. Put the value of VA. When you put this value of VA over here, what we get? We get 0.75. So remember, in this case, VA is 3 meter per second upward, and we know that in the coordinate that we set in that case, upward velocity is negative. So we need to put this VA as minus 3 meter per second. So when you divide that 3 by 4, minus 3 by 4, so what we get? We get basically this thing, that is 0.75 meter per second. And this was what required from the question. Okay, so this is basically the end of question 1 or the end of this example. So what we studied in the previous slide, we have applied it on this example. Now let's consider another example. This example is basically from your RC Hibbeler book, and in this what they are asking, determine the speed of A in figure 1239. Again, it is from chapter 12. If B has an upward speed of 6 feet per second. Okay, so we are having this upward speed of B. Okay, so let's, in this case, again, it's up to us. What they did, they identified this datum plane. And they have also identified the positions SA, SB, and SC. Okay, so if we fix downward motion as positive, so in that case, VB will be negative. Or if we set upward motion as positive, so in that case, VB will be positive. So this problem is almost the carbon copy of the previous one, which we just explained, or the one that we just did. Okay, so in this case, what we have, let's consider this first row. So again, we need to define, but rather than, they have already defined this SC. Okay, so let's find out the length of this rope 1. So it will be SA, and then this length, which is SC, and again SC, and this should be the constant, this constant, this constant, and this constant. So SA plus SC plus SC plus this constant, it should be equal to the total length of rope 1. Okay, when you arrange it, you will get this thing. Similarly, for rope B, this one, the length should be equal to SB, and again it should be equal to this length. So this length can be obtained by subtracting SC from SB. So this one will be SB minus SC plus SB and this constant length, this constant as well as this constant length. Let it be combine both the constant length into C2, and this should be equal to the total length L2. Okay, so when you arrange it, you will get this. Again, to cancel out this thing, let's multiply equation B with 2 and then add both of them together. So when you add both of them together, you will get this thing. Let all constant be shifted towards the right side. Okay, and let's combine them to a single constant. Let the single constant be C, so we get this equation. Okay, so to find out the velocity, what we can do, we can differentiate it with respect to time. So since on the right side we are having constant, so it will be having 0 value when we take time derivative. So we get this equation. Okay, so we have VA plus 4VB is equal to 0. Since we are given with VB and we need to find out VA, so VA is equal to minus 4VB. And if this downward velocity is taken as positive, so 6 should be negative. So over here, instead of VB, what we will do, we will put minus 6. So 6 multiplied by 4 will give us 24, and minus multiplied by minus will be plus. So what we get VA is equal to plus 24 feet per second. And over here it is also mentioned that this velocity is basically negative because we are defining downward as positive. Okay, so now let's consider another example to understand that thing fully. Determine the speed of block B. We need to determine the speed of block B in given figure, which is 1240, if the end of chord A is pulled down with the speed of 2 meters per second. So basically what we need to do, we need to find out the velocity of this object B. Okay, or in other words, this block B, if this object or this pulley or row at point A, if it is pulled downward with a velocity of 2 meters per second. So what we need to do, the first step is basically setting the datum or the origin. So it is already set. Then we need to identify the positive distance or the positive sign, positive coordinate. Let the downward be positive. Then the position. So positions are already mentioned. Okay. And then in third step, we need to identify the constant lengths. So the constant length, again, they are identified in the question. So what we need to do, we need to find out the dependency of both this motion, that is motion at A and motion at B. Okay, so for that purpose, what we can do, let's try to find out the total length of chord A first, and then the total length of this another chord. Okay, so we are having this diagram. So what we can do, okay, so this length can be identified, that is this one. How it can be identified? By subtracting SC from SA. So SA minus SC will give us this length. Then we have this constant, and then we have this length again. It is SA minus SC, right? SA, or let's consider this one, SB minus SC. Since it's on the right side, so let it be SB minus this one. So it will give us this length, SB minus SC. Okay, again we are having this constant, and then should be added plus sp, and then we have this constant line. So what we have, sa minus sc, sb minus sc plus sb, and it should be equal to constant, constant, and this constant. So let's combine all of them into a single constant c1. So sa minus sc, sp minus sc plus sb plus c1, it is equal to total length of chord 1. Okay, so when you rearrange it, you will get this thing. Now let's consider the second row, which is this one. So this one, this line, the first one is sc, sc plus this constant line, and then we have this line. We have line from here till this center point. Okay, so this one is basically sc, and this one is sb. So sc plus sb, but over here we are having constant plus constant, it should be equal to the total length of chord b. So sc plus sb plus constant c2, it should be equal to the total length of chord b. Okay, so we want to eliminate this sc. So what we can do, we can multiply this equation with 2. Okay, so we can multiply equation 2 with 2 and add it with 1. So when you do so, what you will get, this 2sc, it will be cancelled out with this 2sc, and when you add both of them, you will get this equation. So again, this c1 plus 2c2 lt1 and 2lt2, we will move it toward the right side, and whatever we get, we will combine all those constants into one constant, that is c. Okay, so differentiate this equation with respect to time, so you will get va plus 4vb is equal to 0. Okay, since we are given with the velocity at point a, which is downward, and downward is positive, so let va is equal to t meter per second, which is given downward. So put it in this equation. We need to find out vb, so vb should be equal to minus va divided by 4. So when you put it here, what you will get minus 0.5 meter per second. Our vb should move upward with a velocity of 0.5 meter per second. Okay, so let me check. So the problem that we suggest for the topic that we just covered, basically mentioned over here, remember these problems, that is 183, 184, 186 up to 204. It is from JL Merriam book. So you need to go through this problem, and you need to also cover problems which is related to this topic, and which is especially similar to the one that we just covered in our classwork. Okay, so here we are having this small error. The slides are just misplaced. Okay, so what we just did, what we just covered, that was basically absolute dependent motion of two particles. Means dependency of one particle motion on another particle. We just covered that thing. Now let's go through another topic, that is relative motion of two particles using translating frame of reference. Okay, so how we can understand it? For that, to understand the concept of relative motion of two particles, let us consider an example, or let us consider this given scenario. Okay, so let us consider we are having a duck, as shown in this diagram, swimming in a river and moving in some specific direction. For example, in this direction. Let us have an observer who is standing on the bank of a river, and this observer is not changing its position. So let call him fixed observer. We have another observer who is moving in his boat towards this duck, and he is observing this duck from this moving boat. This means the second observer is moving, and imagine that the motion this observer is having, let it be translatory motion. So we can call this observer as translating observer. So we will use this scenario to understand the concept of relative motion of particles. Okay. So to find out the position of this observer and this observer, what we can do, we can select some reference plane, we can select some reference point or some origin. So as this observer is not moving, let him be, or the point on him be the origin. So let this observer be on point O, and let this be a fixed reference frame. To find out the position of this observer, the moving observer, and the position of duct, what we can have, we can have position vector. Okay, let this position vector be RA, and let this position vector be RB. Okay, so RA and RB basically represent the position of this object A and object B with respect to this fixed origin. Okay, which are also shown over here. So RA and RB are basically absolute position of this moving observer or translating observer and this duct. Okay, if you want to find out the position of this object or this duct by considering this observer or by considering our reference on this observer, so what we can do in this case, this one will be the origin, and we will be having a position vector from here till this point like this. So if this is the origin, we can have our coordinate axis at this point. Let this one be z, this one be the x, and this one be the y. And this one will be basically the position of this duct with respect to reference A. And remember, reference A is also moving, it is also translating. Okay, so what we can do to find out the position of B with respect to this moving observer, so what we can do, we can shift our reference over here. And as I have already told you, this observer is also moving. So, and the motion that it have its translation, so let it be translating frame. So this frame of reference that we have given the name as fixed reference frame, and this one as translating reference frame or translating frame. Now to find out the position of this, we can have a position vector from this origin, from translating frame. Okay, so the position vector in this case, let it be RBA. So now over here, when you look at this diagram, what we get, we basically get a triangle. So by studying this triangle, by observing this triangle, we can write this RB by A is equal to RB minus RA. So if you want to find out the position of this duct with respect to this moving frame or translating frame, it should be equal to the position of duct minus the position of this moving frame from the fixed reference plane. Remember, RB by A is the relative position of this object B from reference A. So we get this thing. I hope you understand this thing. Okay, so we can write it RB slash A, that is basically equal to RB minus A. This is the relative position of object B with respect to the moving reference A. And we can also write this RB is equal to RA plus RBA. When you take time derivative, so you will get VB by A is equal to VB minus VA. Or we can rearrange this equation as VB is equal to VA plus VB by A. Okay, if you want to find out the acceleration, so acceleration we know is the time derivative of velocity. Okay, so when you take time derivative of velocity, you will get acceleration of B with respect to A, it is equal to acceleration of particle B minus acceleration of particle A, and both it should be with reference to the fixed origin. Or another word, if we rearrange, AB is equal to AA plus ABA. Okay, so here the acceleration B by A is the acceleration of B seen by the observer located at A. This one. This is basically the acceleration of B while the observer means this is the acceleration of particle B while the observer is at reference A. And at reference A, the coordinates that we are having, that is x dash, y dash, and z dash. And remember that observer A is in a translating frame that is having the coordinate axis represented as x dash, y dash, and z dash. Okay, so now to understand this conceptually, let's have an example. So we are having a train, it is moving at a certain speed, and then we have an automobile, it is also having some speed. So a train travels at a constant speed of 60 miles per hour, crosses over a road as shown in this figure 1243a. So again, this example is from R.C. Hibbeler book, chapter 12. If the automobile A is traveling at 45 miles per hour, if this automobile is having a velocity of 45 miles per hour along the road, means it is following this direction, it is along the road, this direction. Okay, pardon me for my writing. Determine the magnitude and direction of velocity of train relative to automobile. So we are having velocity of this train, which is 60 miles per hour. We are having velocity of automobile, and we need to find out the velocity of train relative to automobile. Or in other words, what we need to find out, we need to find out Vt by A. Okay, so if you look at this one, this diagram, we have an angle 45 over here, which this path which the automobile is following, it is making with the path that the train is following. Okay, so let T is train, A is automobile, VA is 45 miles per hour, then VT is 60 miles per hour. Let theta be 45 degree, which is given over there, and we need to find out VT by A. Okay, so VT by A, from our previous calculation, we can write VT by A is equal to VT minus VA, as VB by A was equal to VB minus VA. So in this case, we are having train and automobile. So let VT by A is equal to VT minus VA. Now VT means the velocity of train. It is in one direction, that is in positive x. Okay. And the xy coordinates are already defined, that x is positive in this direction and y is positive upward direction. So it is having just one component, that is in x. So Vt can have this component, it is having a velocity of 60 mile per hour. It is having a velocity of 60 mile per hour, and it is only in the positive x direction. So Vt is basically 60I. In vector form, you can write it like this. Okay. Now, if you consider the velocity of this particle or the velocity of automobile, remember it is moving along this path, along this road. And road is neither in x direction, neither it is in y direction. It is inclined to x and y with an angle 45. So this velocity will be having two components, one in x direction, which is this one, and one in this direction, right? Or in other words, even if we put our xy over here, so it will be having two components. So the x component should be with the cos, and the y component it should be with the sine. And remember, the velocity is already given. The velocity of this automobile is already given, 45 miles per hour. Okay, so 45 cos of 45, 45 sine of 45, one along I and one along j direction. So when you add both of them, or when you subtract VA from VT, what we get basically this velocity, and this is basically the vector form of velocity VT by A. Okay, if you want to find out the magnitude of velocity that we have of train with respect to the automobile, so we are having two components. Take their square and add them, and then take square root, so we will get that magnitude. If you want to find out the direction, so we can also have the direction. Okay, remember the velocity are having two components, one positive, the other one negative. One positive, the other one negative. So means Vx is along positive x-axis and Vy is along negative x-axis, right? So velocity will be somewhat like this. This is Vx and this is Vy. Okay. So if you want to find out this angle, we can get this angle. This is tangent theta is equal to VTA by y and VTA by x. So VTA over here I was using this Vx Vy, but actually this is VT by a x component and VT by a y component. Okay, so VT by a y component and VT by a x component. So when you put the values, okay, what we basically get, we get an angle of 48.5 degree. So this is the angle that basically which is given by 48.5, or which we identify as 48.5, right? So how we know it, that angle is here, not here. It is from this component. One component over here, it is negative. Okay, and this is also shown in this diagram. Okay, so this was basically the solution that was required. We got Vt by a in vector form, we got its magnitude, and we got its direction. Now again, to further strengthen our concept, let's have another example. At instance shown, car A, which is this one, and car B, both are traveling at a speed shown. Speed are given, one at 65 km per hour, the other one at 20 km per hour. No, yes, 20 km per hour. Okay, the speeds are given 65 km per hour and 20 km per hour. If B is accelerating at 1200 km per hour square, if this is having an acceleration of how much? 1200 km per hour square, while A maintain a constant speed. While A can maintain a constant speed. Means if speed is constant, this means no acceleration. But remember, it's not the velocity. They are saying speed is constant. Speed constant means the magnitude is not changing, but if you look at this object A, it is following a curved path. So mean it is changing direction. So the direction is changing. So we can say if direction is changing, acceleration can have two components. If it is following curved path, one is AT, one is AN. So they say the A maintain a constant speed. So this means this component is 0, but this component is not 0. This component is not 0. It should be equal to V square by rho, or V square by R, and R is given over here. It is 100 meter. Okay. Okay. So let's look at this one. VA is 20 km per hour and it is having curvilinear motion, and VB is 65 km per hour. It is having rectilinear motion. The angle that we have over here, it is 45 degree, and we need to find out what we need to find out. Determine the velocity and acceleration of A with respect to B. We need to find out the velocity of A with respect to B. So we need to find out VA by B, and we know that from previous calculation, VA by B can be written as VA minus VB, and VA by B. Okay, VA over here, if you look at this one, it is following a curve path, right? And if we take our X and Y, if this, let's say this is our X component, this is our Y, let it be the coordinate system that we follow. Pardon me. Okay, let this be X that we follow. Let this be X and this be the Y that we follow for our given problem. Okay, so the velocity V, it is neither in X direction. Over here means the object A is moving it neither in X, neither in Y. Rather than it is moving at a certain angle. So means the velocity can have component in X and it can have also component in Y direction. Okay, so let's see if this is the origin. If we move this origin over here, so it can have one component in x and one component in y. But for that purpose, we need to identify this angle or this angle. Okay, so we have this angle. If I draw perpendicular to this line and perpendicular to this one, so we can have this angle. So this is 45. The angle between perpendicular arm should also be 45. So this angle should be 45. This should also be 45. Thus the total angle is 90 degree. So this velocity VA, it can have a component in x direction, in minus x, and it can also have a component in y direction. So let me remove the extra things. Okay, so it can have component one in the minus x direction and one component will be in the positive y direction. And the magnitude is 20, angle is 45. So the component next should be 20 cos 45, and this one should be 20 sine 45. And 20 cos 45 and 20 sine 45, and component in negative x should be written with minus sign because positive x is given on the right side. Okay, so this is basically for VA we are having two components. Whereas for VB we will be having only one component, and that will be along the positive x-axis. So 65I, the one component of velocity, it will be along the positive x-axis. So it should be 65I, and we have written it as it is. So when you combine both of them, when we find VA minus VB, we get this VA by B vector like this. If you want to find out the magnitude, take these two components, this one, and we can find out the magnitude. So what was required in the question? Determine the velocity and acceleration of A with respect to B. So velocity has been identified, that is 80.4 kilometer per hour. Now we need to find out the acceleration. The acceleration which is A of object A with respect to B. We need to find out this thing. Okay, so remember this object A, it is following a curvilinear motion. So as we know that if a particle is following curvilinear motion, so the acceleration can have two components, right? One is t component, that is along the direction of motion, and the other one is towards the center of that curve, right? This one is known as at, and the other one is known as an. But we already know this at is 0. So the one component that we have is basically an, right? At is basically given by change in magnitude of velocity, which is change in speed with respect to time. So this is 0. And the component along n, it is given by v square by rho, where rho in this case, it is the r, which is 100 meter, right? And the v square that we have, it is already given. V square in this case is 20 kilometer. Okay, so when you put the values in this equation, so you get this an, right? Okay, and we know that this a by b, like VA by B is given as VA minus VB. So A by B should be equal to acceleration of particle A minus acceleration of particle B. Okay, so acceleration of particle A, it should be given by an only, right? Okay, so if you want to find out this an along xy, so we should have two components. Okay, let me change the color. We should have its two components, one along x and one along y. Okay, if this angle is 45, this one will also be 45. So this component will be an cos of 45, this one will be an sine of 45, right? So this is an cos of 45, and this is En sine of 45, right? And this is in the x direction, this is in the y direction, and both should be positive, as you can see. And for AB, the acceleration that we will be having, it will be either in this direction or it should be in this direction. So let's look at the question again. If B is accelerating at 1200 kilometer per hour square, if B is accelerating, right, means its velocity is increasing. So this means the acceleration should be positive. So this is the acceleration of particle B. So let be as it is. So when you put v square is equal to 20 and this row as 100 meter, okay, remember the values that we are using over here, they are in kilometer. The acceleration that we are having over here is in kilometer per hour square. The velocity we have 65 kilometer. The velocity that we have is 20 kilometer. But the radius that we have over here, it is 100 meters. So to convert it into kilometer, it will become 0.1 meter. So 0.1 kilometer, 0.1 kilometer, and velocity is already given as 20. Okay, this is the angle as it is, and this 1200 I. So when you solve it, what you will get this factor. So this is basically the acceleration of particle A with respect to B, or with respect to reference frame B. If you want to find out its magnitude, so take square of this one, add both of them, and take its square root. So you will get the acceleration of particle A with respect to B. I hope that you got this thing. If you have any question, you can ask that question. You can write down on my Google Classroom. Okay, let's have another example. At the instant as shown, we are having two objects, object A and object B. This is object A, and this is object B. Or in other words, we are having two particles. Object A is traveling along a circular path and its speed is increasing at 10 meter per second square. Speed is increasing at 10 meter per second square. It is having a circular path. So this is basically AT, right? So AT is given. Object B is traveling along a straight path and its speed is decreasing at 5 meter per second square. So it is moving in this direction. Let's say if we put x in this direction as positive and y in this direction as positive, so the velocity is negative, but acceleration will be in this direction as the velocity is decreasing in case of acceleration, as it's given over here. If the speed is decreasing at 5 meter per second square, right? Okay, so acceleration of particle B, it can be given as positive. Given as positive 5 meter per second square, and this one can be negative because this is in the opposite direction. However, if you put this one as positive, and this one will be positive and this one will become negative. Okay, so what we need to find out, determine the relative velocity and acceleration of A with respect to B. We need to find out velocity of A with respect to B, and for same case we need to find out the acceleration. These two are unknown. Okay, so now let's look at this one. We know that if particle is following a circular path, so the velocity at any instant, it can be given as tangent to the path, and this is tangent to the path, right? And tangent to the path, this is the velocity, tangent to the path. And remember that tangent to the path is along the y-axis. Okay, so the velocity at A, it is having only component along y-axis, so A should be 4j. Okay, x is positive in this direction, so we don't have any component of velocity in this direction, whereas velocity is having one component. in the x direction, but this is in the negative x. So VB should be minus 8i. So VA by B should be equal to VA minus VB. And when you put the values, you will get this vector 8i plus 4j. If you want to find out its magnitude, so we can find out the magnitude by taking square of this one, taking square of this one, add them, and then take square root. So we will get the magnitude of A with respect to B, magnitude of velocity of particle A with respect to B. Now let's look at the acceleration. Okay, if we consider acceleration of this particle, so they are saying that the speed is increasing at 10 meter per second square, and we know that change in magnitude basically given by at. So at is given over here, and an is basically given by equation which is v square by rho. So this is particle A, so that's why we put this v square A, and this is the radius rho, which is given as 0.5. So put this value VA as 4 meter per second square. So this one will become 16, and this one at 0.5. So when you do the calculation, you will get 32, right? So the component along x-axis, which is AN, it will be represented with unit vector I, and it is given as 32i. And AT is already given. This T component is already given. So now we have AT, AN for particle A. This A basically represent particle A, and this small a represent acceleration, T represent tangential, and N represent normal. So if you have these two combined, you can combine them. When you can combine them, you can get the acceleration of particle A in vector form. And for particle B, they are saying that it is decreasing, the velocity is decreasing at 5 meter per second square. So means acceleration is 5 meter per second square. And it is along the x-axis, positive x-axis, right? So AB should be equal to 5i. Now what we need A acceleration of particle A with respect to B, so it should be equal to acceleration of particle A minus acceleration of particle B. Okay, so this should be equal to this one. Put the values of acceleration of particle A, acceleration of particle B. When you do the calculation, you will get this equation. Okay, if you want to find out the magnitude, take square of this one, take square of this one, add both of them, and take their square root. So we will get this thing. So this is the answer, or this is the required answer which was required. What was required? The relative velocity and acceleration of particle A with respect to B. So this is acceleration of particle A with respect to B, and this is the velocity of particle A with respect to B. Okay, so this was how we can find out the relative motion, or how we can analyze the relative motion of two particles. Okay, to get your concept clear, to get your concept strengthened, the suggested problem for you, they are basically given over here. And again, remember, these problems are from your book JL Merriam, Engineering Dynamics. Okay, if you are having any question, you can ask me to email, or you can post your question on your Google Classroom. Okay, thank you. I hope you have a good class.